And I'll share a couple links in there too. I'll share these again when we get to the hands-on code part, but what we're going to do is first go through some slides, and then we're going to do some hands-on coding. At least I hope a lot of people here want to do the hands-on portion and actually write a workflow. So we're actually going to build a fine-tuning workflow. We're going to download a model, download a data set, fine-tune a large language model. We'll visualize the data set as well. We'll evaluate the model, and then we'll do a couple different ways of doing prediction with it. One way is we're going to build a live application that you actually have the LM deployed to and be able to interact with it. But first, to follow along, one thing you'll need is just a free account from Union. You can go there. There's no credit card or anything required. You just need a GitHub account to authenticate into it. And then you get $30 of credit, which is more than enough for what we're going to use today or do today. And then the other thing is here is a link to the GitHub. So that's going to be the code that we're going to follow. There's a little button you'll see, and again, I'll go through this as we get to it. But there's a button that says Open and Collab, and that's going to be kind of the tutorial we'll run through. Again, after the slides, I'm going to do some slides that set up the concepts, so everyone's kind of on the same page. We're going to talk about some best practices for implementing MLOps in your company. And then also I'm going to share one more link. This isn't relevant for the workshop here, but we are. I'm going to share a link to Slack. So if you have questions later for me or anything about that you're gonna see here, you can join the Slack and ask questions. So with that, I'm gonna go into the full slideshow. And again, we're gonna build a workflow looks like this, and then we'll actually deploy a model here. A tiny bit about me is I work at a company called Union. We're going to hear a little bit more about that later. It's the tool that I shared to sign up for. It's a AI workflow and inference platform. So it allows you to build best practices for your MLOps team, including versioning, declarative infrastructure, so you can easily write the code you want, but then declare the compute you want it to run on. And again, we'll see this in action. I live in Seattle. I also run an AI book club, so if you connect with me on LinkedIn, you'll probably see more about that, which I'll share the link for that as well. So if you want to stay connected, you can find me on LinkedIn. And previously, I've done a lot of work in computer vision, ML monitoring and evaluation, MLOps in general, and then also have a background in hardware with like IoT, robotics, and manufacturing. And then I know that I think there's quite a few people here. If you want to put in the chat, I think it's kind of fun to see kind of a little bit more about people, like where are you watching from? What are you working on? Maybe why you're interested in ML pipelines. If you want to put that in the chat right now, it's kind of fun to see like people's backgrounds. What are you learning right now? Why do you want to learn about ML pipelines and fine tuning? Put that in the chat if you want to give a little more details about yourself. And then just kind of a quick recap, or a quick, I guess not a recap because we didn't talk about it yet, but kind of a quick intro to what MLOps and LLMOps kind of is. It's really a set of best practices, and I wouldn't say it's actually the tools themselves, but it's the best practices and combining those tools that aim to deploy, monitor, and maintain machine learning models in production. And then I like the terms reliably and efficiently. And usually you're going to have some sort of pipeline that looks like this. This is a very bare minimum pipeline. So usually you'd have many more things in here. But usually at a bare minimum, you're going to have something like collecting data. You'll probably pre-process the data as well. You want to train a machine learning model. It's going to learn from that data. You want to evaluate that model, making sure that it works kind of and behaves as you want it to. Then you're going to ship that model somewhere. Shipping that model can be very different depending on what you're doing. So like I had mentioned, doing stuff with computer vision hardware, I've shipped models in like computer vision models to edge devices, literally in like crop fields and stuff. And that's very different than hosting your model on a cloud somewhere that you can have access to all the time. So there's a whole bunch of different ways you can ship models. Once you ship that model somewhere, you want to think about usually how to monitor it. If you just put a model on production, chances are at some point it's not going to start behaving or it's going to start behaving differently or not be as accurate as it once was, and you want to be able to catch that quickly. And typically you're collecting data in production or data from somewhere else, and you want to fine tune your model, or maybe that's even prompt engineering or something like that with large language models. And you basically want to be able to improve and then do these steps over and over again. So typically you want to ship a model, monitor it, and then make improvements, whether that's collecting production data, then fine tuning on it, or doing something like, again, like prompt engineering different ways. And then again, usually you have way more in your pipeline, like you want to process data, you might have vector databases, you need to create embeddings from data. You might have guardrails in your large language model, so you want to add stuff in so it's not going to be answering questions about stuff you don't want it to. And then also you might have like A/B testing and deployment. So as you change a prompt or fine tune a new model, put it on production, you might want to look at how the new model is behaving versus how the old one was behaving before you make that actual switch to putting that new model in production. Fortunately, there are many great tools that make this way easier. You've probably used some of these tools if you've done any machine learning before, whether more traditional machine learning with like scikit-learn, or if you've been doing deep learning or large language models. You see Hugging Face in here. So, we have all these tools that we can kind of tie together to make this process much easier. And at the core of building the pipeline, like with those tools, you have something called workflows. And building these out in an efficient and reliable manner can really help your team improve cost and efficiency. And then sometimes you also want to think about compliance. And I always like to think about collaboration as well. So and scalability. So you want to facilitate the scaling of your AI workflows. This can be, like we actually work with a lot of self-driving car companies, and when they're training models, their data sets are really, really big, and they need to spin up a lot of compute to handle the training of their models. And then you have reproducibility. So you want to ensure that the workflows can be consistently reproduced every time you rerun them. Again, going back to kind of that this slide, you're rerunning workflows pretty often as you get a new model, and you want to have consistent environments across all those different tasks, so that's you're not getting anything different or weird in there. Yeah, versioning. So you've probably done some sort of versioning like with code before, but you also want to often, or in my opinion, kind of, if you can, always version your whole workflows. So you want to track the data, the code, and the model versions. And sometimes like this is always good for most teams to do. So you can easily roll back, kind of see what was going on before if you need to understand what happened and why a model's behave in a certain way. But in some fields, this is actually required more, where you have to think about compliance, like in the financial industry or healthcare. This isn't necessarily negotiable. And then you want to think about improved efficiency, where you allow data scientists to actually focus on the code and building the cool models and stuff like that, instead of configurations for basically their compute environments. So we want to basically allow our data scientists and AI engineers to iterate much quicker. And then also with that, you kind of want to think about cost efficiency. So resource usage, reducing the overall cost of developing and deploying models, and all these kind of things are usually tied into workflows. And they can really, really help your team go way faster and usually be way more efficient, both in time and in cost. So usually when I'm implementing or helping people implement these kind of pipelines, again, I really like to think about cost. Again, companies often care about that. Optimization, not just for cost, but also for developing and deploying models. Collaborating across teams, you want to be able to hand off artifacts easily from team to team. If you have a larger team, you might have a data engineering team, a machine learning engineering team, and then also a shipping model kind of team. So just to hammer on a couple of the things that make a huge impact in efficiency when helping people kind of develop a best practice ML pipeline is optimizing for local and cloud development. This kind of might sound obvious, but not every type of workflow tool makes it easy to do local development and then cloud development. So often when you're going to do like a fine tuning or training a deep learning model, you're going to be using GPUs in the cloud. But when you're building your pipeline for the first time, and as you do when you code, bugs pop up. Instead of kicking off a cloud job, waiting for like containers to spin up, and then hunting down for the error, you can save a lot of time by developing a version of your pipeline. Maybe even uses a smaller model, maybe uses a small sample of the data set when you run it locally. But you can basically run and debug this pipeline locally before you kick off a cloud production job. So this sounds like a no-brainer kind of thing, maybe. But it's actually one of those things where it's kind of simple, but saves teams a lot of time. So when you're kind of building out your pipeline infrastructure, this is one thing I recommend people think about. Leveraging caching in the pipeline and in workflows. So here, this is an example of like training a workflow or a workflow for training a model. kind of similar to what we're going to build today, actually, in person or hands-on when we run the code. We'll actually implement this with caching. But here we have a training workflow. We're gathering data, we're pre-processing that data, and then training the model. And let's say we're going to rerun this whole workflow quite a bit of times for like hyperparameter tuning or something like that. Instead of downloading the data set and processing the data each time, we can just have those tasks cached. And it doesn't have to be downloading or anything like that. This could be any task you think of in your pipeline, where when you rerun a whole workflow, you could just have a cached version of the output there and then read it into the next task. So this saves a lot of time and sometimes costs and resources from not rerunning compute for those tasks. Tasks and another thing on compute management and resource management is the task level resource management and containerization. So being able to precisely attribute resources to tasks that basically you want to only use like GPUs, for example, or high compute when your task needs it, and then you want to have smaller amount that costs less on tasks that don't need it. So going kind of back to this example, if we are training a model here and we have like GPUs that are pretty expensive and maybe we don't have as many in our cluster and we want to reserve those for people that need them, all these other tasks we don't want to run on a GPU, we just want it to run on CPU. So here we can actually declare per task what compute infrastructure we want it to run on. So when we're doing our training, we want a GPU. When we're just downloading a data set, we just want CPUs. And again, we'll see this in action too, how we can actually do this. And this is something that, again, saves quite a bit of time and resources usually when you implement it into your pipeline. And then one other thing is, again, this might sound obvious depending on your background, but mitigating errors with type safety. This kind of makes your code a little bit more shareable and readable for people. So if you're just used Python before and you haven't done type hinting, Union and Flight, the open source that I'll talk about shortly, we enforce this. And you might want to think about enforcing it, even if you're using different frameworks, where you basically have to declare the type of data coming into a task and the type of data coming out of a task. And then if you do something different in that task, on compile time, it's going to yell at you. So this is really just about faster debugging and then also kind of the collaboration piece between teams. And today, to kind of implement all those things, we're going to be using Union. So like I mentioned, we're a workflow and inference platform. A lot of the orchestration side, like building those pipelines, can also be done in Flight. So if you want to check out the GitHub, you can check out Flight too, which is the open source that our founders created when they are at Lyft. That's kind of why it's spelled that way with the Y in there. It was their internal orchestration tool, and then they open sourced it, and now it's run by the Linux Foundation for AI and Data. So it's actually used by thousands of companies in production for their work, like the data and ML workflow side of things. And we'll see this in action, but basically you're going to write code like you normally would, except for we do enforce the typing. So here we're saying, this task of downloading data is going to output a pandas data frame. And then we just have this kind of task decorator above the Python function where we're saying caching is equal to true. What version of that cache is that? What container image do we want to run on? And we'll talk more about container images shortly, but basically every single task in here is a different container. But if you've never worked with containers or Dockers or anything like that, or Docker files, don't worry. We actually make it really easy and kind of make it feel like you're not developing on something like Docker or Kubernetes. So Flight and Union is built on top of Kubernetes. So we spin up all these containers for your tasks and we make it really easy to scale. But we make it really easy to work with it. So it doesn't feel like you're configuring all these different things for your Kubernetes cluster. Someone at a conference that I was demoing at, they said, wow, these are the hardest working decorators, which I thought was really fun. So again, we'll see this in action with using declarative infrastructure, versioning, caching, type safety. There's a big plugin ecosystem, but also it's just really giving you Python compute infrastructure. So almost anything should work anyway, even if there isn't necessarily a plugin. Plugins usually just make it kind of easier. There's checkpointing, and then we'll see there's a user interface and an API. And yeah, like I mentioned, it's used by like thousands of companies, Flight and Union. And then the model that we're going to train today is a BERT model, which it stands for bidirectional encoder representation from transformers. A lot of the use cases here, you can use it. It's a lighter weight kind of transformer model that we can use for like text classification, semantic search, named entity recognition. But what we're going to do today also transfers over to almost any other type of large language model. So you can actually just change a few lines of code, and then you can have like a chat model running with kind of the stuff that we're going to see today. If you want to read more of the BERT paper, I will share this in the chat as well. And then, all right, so let's build the pipeline and have this example running. And I saw there was a lot of chatter in the chat. So I'm going to look at that as people are opening this up as well. So here's the code that we want to run. And then again, you want to sign up. Again, it's free. There's no card required or anything like that. You just have to authenticate with your GitHub account. And then you get $30 of cloud credit. So no card or anything like that. Should be easy for you to sign up. One thing I'll note, I think it takes 3 to 5 minutes for it to process you. And then you should get like an onboarding email. So it's a perfect time to open up the code and sign up if you haven't already. I open up the code here, and then I'm going to scroll down, and I'm going to hit open in Colab. And then once you have this in Colab, I like making my own copy kind of when I'm following along or running a workshop. So you could change the code, change the text or anything like that, and you can have your own copy saved. So I would recommend opening up that Colab link and then going to File, save a copy in Drive is my recommended way of running it. Someone asked, why should a data scientist care about using Flight or Union instead of their current workflows? Well, I don't know what their current workflows are, written in Python and using frameworks like PyTorch. So we actually are using PyTorch and Hugging Face in here. Flight and Union, as we'll kind of see here in a minute, they give you a way to really easily run reproducible and versioned workflows and share visualizations and pass artifacts out and share artifacts between teams, and declare the compute that we want to run on. So we'll see this in the code. Actually, well, let me have you download something, but we'll see in the code, and I think you'll see why you'll want to use this. First, if you want to scroll all the way down, this can take a minute to run. So I would scroll down to this kind of tab here, or this code cell with this try import, and then hit run on this. And I'll go answer the questions as we're going. So you can hit run, or if you have a code cell, you can hit shift enter. Someone asked, is BERT fine-tuning still relevant in the LLM era? I mean, it is LLM. And it is actually, there was a new version of BERT. So this is kind of the older one. There's one called modern BERT, I think. So it's a lighter weight model. Depends on your application. Like if you want to do a 0-shot with a foundation model, you can, but deploying that onto an edge device or something like that isn't always feasible, like if you don't have an internet connection. So if you want to train a lighter weight model that can do really good classification on unstructured data, that's where like BERT falls in. And we're going to see today too is the fine tuning part of the pipeline in Hugging Face. And like I'd mentioned, this kind of converts over to other types of large language models. So if you want to fine tune a different large language model like Llama or P4 or 5.4, Gemma 2 on a specific data set to learn knowledge about something like healthcare, et cetera, you can take what you're going to learn today, change a few lines of code, and do this with a different type of large language model. And I'm actually working on doing another example with a chat applications versus BERT. One reason I use BERT too is you don't need a ton of resources to train on, and it can train pretty quickly. So you'll actually see, like, you'll fine tune a model and then be able to interact with it today. So I'm looking for a good data set and a lightweight enough model that behaves pretty well that we can come away with. So if you come back to another workshop like this, I might be using a different example next time for fine tuning. But for this, we are fine tuning a sequence classification model that you're going to train, and then give it, data and get predictions back. As this is downloading, let me scroll down. So I'll come back to these code cells for authenticating. But someone asked like why you want to use FlightKit or Flight or Union. There's a couple things. So one, building container images and managing them can be kind of difficult across teams. Two, then you want to declare infrastructure that you want your workflows to run on. So Union of Flight is bring your own code, bring your own models, bring your own data. You interact interact with this with Python, and most people use this with Python. So this is an example of a very, very simple workflow. We'll go run this, but first we're downloading all the packages. And actually, the longest thing here isn't downloading the packages, it's uninstalling some of the pre-installed packages that Google Colab has installed here. So usually it wouldn't take this long if you're running this locally. This is the example of a super simple workflow. We are creating an image here with this image spec feature of Flight and Union. So we give it a name. We're going to pass in the packages we want. In this case, we're just installing Flight Kit and Union, but this is where you would pass in different packages like PyTorch or Hugging Face or Accelerate libraries as well. Again, we're giving it a Python version. We're going to read what version we have from the environment here, and then we're going to pass that in. And now that we have this image defined, we're going to run a task. So a workflow is a collection of tasks. So this is actually what we're going to build after that simple workflow. We're going to download a data set, download a model, train a model, visualize the data, evaluate the model, and then we'll do a batch prediction here, but we'll also see how to deploy a model in a live kind of running app. And basically, each one of these nodes is a task, and then a workflow is a collection of the tasks. So here we're defining our first task, and we give it a container image, and it's going to look at this image that we defined above, and the Union builder is going to say, does this image exist? Yes or no. If it doesn't, we're going to go ahead and create it. And then we're going to define the resources. So this is a super simple one where we're just kind of returning a string from our task. So for the compute for this one, we're just defining 1 CPU and 1 GB of memory. But we'll see later, we'll add GPUs to this and we make it really easy. So as you're writing your code here, you get access to the infrastructure you need to develop your apps on. And then here is our task. So you can see that this is just like a Python function. Again, we enforce typing though. So we're saying the data coming in is going to be a string, and then it's going to be returning a string. And then we'll just return that. And then we have this workflow decorator. Again, our workflow here is just one task, but we'll build a more complex one later where we're going to tie the flow of data between tasks. All right, so mine is done installing. So I'm going to scroll up, and don't worry if you get some pip dependency errors here. Don't worry about that. It's just kind of saying that Torch Vision is looking for a different version of PyTorch, but we're not actually using that today. And that comes with the thing where Google Colab has some pre-installed packages, and we overwrote some of them. So the thing we want to do first is authenticate to the Union platform. So I'm going to go ahead and run this code cell. And we're authenticating to serverless. I should mention, so serverless is kind of a lighter weight version of our enterprise version of Union, where it has most of the features that we talked about. It just doesn't have like role-based access, and it's like a single seat kind of thing. So it's really good if you want to play around with building workflows. So this gave me a URL. I clicked on it, and then I didn't change any characters in the thing I opened up, and I just hit authenticate. And then here, now I'm connected to Union serverless. And if you were to go to just serverless.union.ai, you should be able to get a dashboard. Yours will look very empty right now until we do our execution in the next kind of code cell part. But if you were able to authenticate and then open that up, we should be good to go. All right, so I talked about this already. Now we should be able to run it if you're authenticated. So I'm going to go ahead and shift enter here or hit run on this code cell. One thing I'm noting too, so for this portion of building our task and workflow, we're actually just doing this directly in a notebook cell, which is kind of cool. So you can actually build production grade pipelines directly from your notebook now if you want. So we declared that task, the workflow, and then we're using the Union Remote API. So we're initializing that, and the Union Remote API allows us to do kind of anything that we see in the UI later remotely in like the Python SDK. So we initialize our Union Remote connection, and then we are executing the workflow that we just defined above, and we're going to pass in the name parameter. And this is a text or a string here. So I'm just saying flight, but you could type in your name here if you want to change this. And let's hit run on that. And now it's executing, and it should give me a URL. So for me, I've run this before. So it's not building a new image. So we define that image above. It's looking, hey, does this image exist? Yes, no. In my case, it does exist, so it's not building it. It says skipping build. Your first time running this, it'll have to build an image, so that might take a minute here. And then you'll get this URL that you can click on, and it says execution in progress. I'm going to click on that. It's already succeeded here because it was a very lightweight task. And we have this very, very simple pipeline. Again, we're going to build our more complex one here in a minute. But we can see we have this hello world. I can click on this. I have inputs versioned. So here we can see the string that I passed in, the parameters. In this case, it's a string. We can see outputs. In this case, the output's just a string here too, combining the parameter we passed in, flight, with hello. And we have some other task versioning things here. And if I want to, I could rerun the task directly from the UI. Like I mentioned, you could do all this from the Python API as well. I can also relaunch the entire workflow. So let's do that. I'll change this to Union, and then I'll hit launch. And in this case, again, our workflow is very simple. We'll be building a more complex one here in a minute. But you can see that we can relaunch workflows just from the UI, or again, you could do this from the Python SDK. And relaunching a workflow like that, where you can change the parameters in your launch form, makes it really easy to do things like hyperparameter optimization. Or if you want to give this workflow maybe to a non-AI engineer, and you want to have them be able to adjust things like dataset strings or something like that, it allows people to do pretty fast experimentation and then rerun this whole workflow. You have this different views, node, I like graph. The graph looks more interesting as we add more tasks here. And then now you can see that this has a version attached to it as well. So I'd mentioned every single workflow's version. This is all snapshotted, so you can always go back to different versions and grab different data out of them. So again, this becomes more important when you're training like a model and you want to go back and see the lineage of the data set. You want to see the lineage of the model. You can see that all kind of in the UI very easily here. You could click on this version, and it'll bring you to this workflow area. And then you can see like each all these are different versions. This is the latest one. And then you can click back in basically and view the artifacts for each one. All right, so I'm going back to the notebook. Let's also, you can pull down data. So we make it really easy to go from, I guess, kicking off these production grade pipelines and then pulling data back into notebooks, which is really cool. Now, if you were able to run this, everything else should run super smoothly. And we basically want to build our more advanced pipeline now, where we saw we're going to download a data set, download model, fine-tune a model, and then all this is versioned. And we can even embed visualizations. So if you want to kind of see analysis of what your data set looks like and what your training looks like or anything like that, you can embed this into a workflow and have this all versioned as well. So I'm back in the notebook. I'm scrolling down. What I'm going to do is, again, I think you should run this code cell. It's going to take a while to run the whole training pipeline and to like build your container images. And while this is happening, I'm going to walk through all the code. So if you are following along in Google Colab, it has some instructions here, kind of where we're going to find the code. So in this case, we are running them from .py files. And if I want to navigate to anything we have downloaded here, I can hit this folder icon. This brings up the Git repo that we installed when we were installing libraries as well. And we have this task and workflow folders, and we have a few other things that we'll open up later. But for now, I'm going to open up this workflow, train.pipeline, and I'm going to double click on it, and then I'll bring it in. Hopefully you can all see this pretty good. Let me know if I need to zoom in more. And if I scroll down, we can see here's the pipeline. We have a @workflow decorator, kind of like we had before in a very simple one. This time we are calling, we're passing the parameters like the model name. Again, you could change this to a different string for a different Hugging Face model. And we'll see how this is used later, but we're downloading a model from Hugging Face based on that string. The amount of epochs, so the amount of times that our model is going to look at the entire data set that we pass in and then learn from it. And then these are some test cases that we're going to pass into our model, see what it does for a prediction on them. And then this is our actual workflow here. So we can see these are all different tasks. And I'm going to open up the task file here in a second, but we're calling download dataset. We're getting 3 things returned: a trained dataset, validation dataset, and a test dataset. Typically, when you're working in deep learning, you want 3 different types of datasets here. Training dataset, your model looks at all of that. And then validation, you kind of use as your model's training to see how it's doing. And then you can adjust hyperparameters, and then usually have one more test holdout data set that you can validate your model on. Then you have a saved model directory is returned. We're downloading a model, we're saving it, and then we're going to uh, read this into a directory and then read it into our other tasks. We have our visualize data task, and then we have our train task, which is taking in the stuff we already downloaded, and then we have evaluate model task, and then we have a predict sentiment task here. If I go into my tasks and I go into this model.py, this is where most of those live right now. So I'm going to scroll through this, and I'll go kind of quickly here. And again, let me know if your task is actually running or not. Like if I go back to the notebook, mine is executing here. If I do open this up, should give me basically says these two are already run. Part of the reason why they have already run is we have caching, which we'll see here in a second for these. And then it's training my model right now. And yours will probably look like this soon, if not already, because it might be building the container image first. All right, I'm going to talk about kind of the just stuff we imported as we go. First, I guess I should mention, so we are importing from containers.py, container image. You don't have to open this up if you don't want to, but in containers.py, we're basically just building a container image based on our requirements.txt, which has all the things like Hugging Face, PyTorch, transformers, etc. in there. And then we're saying we want to run on that container image. In this case, all of our tasks are just going to run on it. But you could have different container images for different tasks if you wanted to. So here I'm passing that container image to this task, and then I'm saying I want caching is equal to true. So every time I rerun this workflow, it's going to read from cache by default for this, unless I update this cache number. And then we're saying for downloading the model here that I just want 2 CPUs and 2 gigabytes of memory. I actually don't need a lot of resources here just to download something. But when we train our model in one of the next steps, that's when we will add in GPUs. And so again, adding this kind of decorator above your Python function is one of the biggest kind of developer experiences for using like Flight and Union. Make it really easy just directly in your code to get access to the infrastructure that you need. And then here we have our download model. It's taking in a string. That's where that BERT uncased string comes in. We're returning something called a flight directory. So if you're new or to developing with containers, like I'd mentioned, this is built on top of Kubernetes. It's okay if you don't know anything about Kubernetes, but it's a way to kind of orchestrate and manage containers and compute. And so each of these is running in a container. So that means when it downloads the data set, it spins up compute like a compute environment. And then when it's done, it spins it down. So it's kind of a different mindset shift if you're working with containers for the first time about like when you do something in there and then it spins down, it doesn't exist anymore by default. So you need to make sure that you can easily pass data out of those tasks to other tasks or write it to a directory. So then it's persistent. And that's where flight directory and flight file comes in. So when you just say that the output of this task, you want it to be a flight directory or a flight file, it's automatically going to write it to a storage, and then you can access it from other tasks. So it's an easy way to develop with containers and have kind of persistent data between different tasks. So in our download model, we're getting our working directory, and then we're just saving that model to a directory, and then we are reading in. So Hugging Face has a thing called auto model and auto tokenizers for different model types. So again, we're using a sequence classification model today, but you could have this be I forget I think it's causal ML, and that could be like the chat version of an LM. And we're saying from pre-train, we're going to pass in the model name, device you want it to run on, do you trust remote code, etc. And when we pass in that model name, then it's going to go ahead and look for that model, and if it doesn't exist, download it. And then we're going to do the same thing for tokenizer. And then basically we're just saving that version of the model and then returning it as a directory like I mentioned. So then we can access this in our fine tuning task. We'll read this model in, and then we'll be able to update the weights on it. And before I go to the train model, I will actually open up data.py real quick. Hopefully it's real quick. See if Colab opens it. Hooray. Awesome. So in here, we're downloading the dataset. The dataset that we're using today is a IMDb dataset of movie reviews. So we're basically going to train our model to look for negative or positive sentiment in this unstructured data. And then you'll see at the top here, I've defined 4 artifacts. These are ways for me to define artifacts in Flight or Union where I want to basically save these and then be able to access them from any workflow, pass them off to different teams, have them all versioned. So in this case, I'm doing some processing to our data set where we're saving the train validation test. And I want to be able to put those aside so that I can pull them in anywhere. And I'm doing that also with a model when we train it. So that we train our model, now it's saved somewhere, it's managed, we can pull it into different workflows, different people on my team could use that model when they deploy a model. So we have our download data set. This is similar to what we saw before for downloading a model, except for we're returning this annotated flight file with the artifact that we defined above. Annotated is a type in Python where you can return like a file with some metadata, and that's currently how we define and return these artifacts in Union. And then we're just downloading the IMDb dataset from Hugging Face. We're training the model. So basically, we're getting the trained data set. So we're extracting train from the data set, and then we're storing it into a data frame here. And then we're doing the same thing with test. And then we basically want to make one more version of our data set, the validation one. So we're doing something called train test split, where we're saying 20% of the data we want to set aside for another data set, or validation in this case, and we're calling stratify. On the label, stratify basically means we want to get as even of a number of each label as possible, so we're not like overfitted on one single label for that data set. And then here, we're again just defining working directory and saving all these as CSV, and then we're going to return them out so that we could read them in to our training task. And then for visualize data, and I'll open this up just so you see what we're building again. I think I showed it, but it was pretty quick before. So we have this visualize data task, and we're going to read in all those data sets, and then we want to have visualization for them so we understand, or sampling, so we understand what our data set was. And I usually like to do this for any type of data that I'm working with, have some sort of visualization or understanding of it so that when I go back and see kind of what was in my workflow, I have a good understanding why maybe my model that I fine-tuned with it is behaving the way it did. Same with like not just text data, but any other type of data. For computer vision, I always like to read in a sample the images, in a sample the annotations. So if you're doing something like object detection, you have bounding boxes drawn on it. You can read it in here, making sure that the bounding boxes were like read correctly and annotated correctly. Here we have those three data sets that we passed in. We have training data set summary, and then we have the chart of the distribution, which this is a pretty clean data set. So the distribution is actually the same here, but this would be really helpful if you have a data set that isn't like a clean one from Hugging Face for this tutorial. You can see the distribution of all the different labels. And then I have an example of a positive review and a negative review, so I get an idea of kind of what the text looks like. And I do that for the validation and test data set too. So again, this is really helpful when I have whole versions of these workflows and I want to come back and see, like, why did the model behave the way it did? So to do that, we have our task above our visualize data function, pretty similar to what was there before, except for we are enabling deck, which gave us that button. And then you can embed any HTML or Markdown in there, including things like Plotly. So if you actually want advanced visualizations of stuff, you can do that as well. Then we are basically just reading in the CSVs that we had saved before as artifacts. And then we're just getting the first positive and negative review from each one so we can display it. Then we have a function that just plots the graphs that we saw, and we do that for each data set. And then this is just an HTML report. So again, you could basically make this as complicated or cool as you wanted to and embed it as a visualization. Then we're just appending the HTML report, and then we're inserting it in slot 0. So it means when you open up this deck, oops, not debugger. If we open up deck, it'll be in this first slot here. All right, so then let's go back to our model.py, and we'll go to the training model code. So here is where we're actually going to fine tune the large language model. Again, you could do this with different types of LLMs as well, not just the BERT one. And here we're requesting 4 CPUs, 12 gigabytes of memory, and then 1 GPU because I actually want to use a GPU for fine tuning, which if you did it on CPU, it might take forever. And by the way, in Flight or Union, you can specify what the default GPU is. So in serverless, our default is an L4 NVIDIA GPU, but there's actually A100s in there too. So you can import different accelerator types and then define those. Also, when you have like an enterprise version, you can set up kind of what do the defaults look like. So GPU equal 1 could be a 100 by default if you set it up like that. Then we have our function that we're declaring, train model. We're returning, we're taking in a model directory. This is the model that we downloaded, again, as a flight directory, so it's persisted across those containers. Then we have our train data set, which is a flight file. Again, that's the type of file that we saved, and we're able to have persistent storage. Same with validation data set, and then the number of epochs that we're going to train for, again, is default 3, but we can update this in our launch form, or parameterized launch form. And then we're returning an artifact, so we'll be able to read this in from other tasks. So we'll actually use this in a little bit. We'll pull it into an app and be able to serve that application. Here, I'm just making sure I download that model directory. So it's a kind of a large file. I pass it in here. I'm calling model directory.download on it. That's just part of the passing a flight directory. You can make sure you download it into your next task. Then we're initializing the model, which again, we're using auto model for sequence classification in this case, which allows us to pass in a string and then be able to read it. And then same thing with tokenizers. And the tokenizer, if you don't know, is the way that LLM kind of chunks up the data. We're reading the same tokenizer for our model. And then we're declaring our train data set and our validation data set. Again, those are the CSVs that we passed in. One thing to note for this example is I'm limiting the number here to the 500 examples because there's like 20, or I think in total there's something like 50,000 samples in the entire data set. And that would take a long time for us to train on. So we're going to start with these 500, and then we're going to validate on 100. And you could update this number to be a lot more if you want to right now, but it's going to take a lot longer for your workflow to run. So the purpose of this is that we can kind of quickly go through, run a workflow, get it trained in a good enough state to mess around with, but we could probably improve this by adding more data, maybe even more epochs, which is, again, is the amount of times it looks at the data. And then we're going to initialize the CSVs basically into the Hugging Face dataset format. So we're calling dataset from pandas, and then we're passing in those datasets. And this will be in the format that Hugging Face needs to start learning from it. Then we have a tokenizer function. So it's going to tokenize the data as it reads in. And then we are mapping over the trained dataset, validation dataset with the tokenizer here. Then we're going to pass in some training arguments. So in this case, we're just basically going to output things and results. And then the main thing here is we are passing in the number of epochs. So again, for us, it's going to look at the whole entire data set 3 times. But you might want to add that in more. There's also something called early stopping. So you could add in like way more. And then if it hasn't been improving or learning from looking at the data set more times, it can kind of just stop and save the best version of the model that it has. And then we're calling or initializing trainer. So again, we're passing the model from Hugging Face, the training arguments, which we declared above the training data set and the evaluation data set. And then we're going to call .train, and that's actually going to update the weights of our model. One thing to note too is just by default here, we're going to be updating all the weights of our model, but there are different ways to fine tune LLMs, especially if you're working with really big ones. You might want to look at more parameter efficient fine tuning. And I'll be building some more examples around this too. So if you connect with me or follow me, you'll probably see some of this soon. But there's parameter efficient fine tuning methods. Common ones are called LoRa, which is a low rank adapter, I think is what it stands for. Yeah, something like that. So you're basically, instead of training the whole model, you're training a smaller matrix in the model, and then you can get really good results from it, but without having to load like the whole model into your GPU and update all the weights. So you can do it on lighter weight hardware. And there's also another version of that called QLoRa, and the Q stands for quantized. Oh yeah, and someone mentioned Unsloth. So Unsloth is a really cool library for that as well, where you can basically be able to fine-tune models more efficiently. And they have a whole bunch of already fine-tuned models or quantized models on Hugging Face too. Have you used Unsloth a lot? And then we are basically here, we train our model. So again, there's a whole bunch of stuff for you to look at to do this more efficiently. If you want, especially when you're working with larger models, we don't really need to do it with the model that we're using today. But then we're just going to save this model that we trained, and we'll have it as an artifact fine-tuned model, create from the output directory here. And then we'll be able to take this model, pass it around to different workflows or to our deployment piece. And then we have our evaluate function. Again, I'm going to go quickly here so we make sure we can do the deployment piece next. Nothing really new in here. We are enabling deck. We want GPUs again. We're downloading, or we pass the model and the test data set here. And then we're basically just doing classification metrics that we want to log here. And actually, if I go back to my workflow, I could pull up this evaluate one, look at the outputs, and for that model that we just fine-tuned, in this case, the accuracy was like 86%, and then you have some of the other scores like precision versus F1 score, all around the same, like 86 here. So pretty good for just looking at 500 samples and just 3 epochs. And then if I did go also look at this other one, this batch sentiment prediction, and I look at outputs here, or actually, let's look at inputs first. This is where you just pass that kind of generic text in. I like to have kind of another sample data sometimes in my pipeline to see how it's performing. Sometimes I'll make this really different than what I know is in the training data set just to see how it performs. In this case, it's really easy, but this actually is different from the training data set. So if we look at the training data set, the reviews are very long. But this obviously has the word great and bad, and it's probably picking up on that. And then we can see the outputs here was label 1, which is a positive sentiment. And then this one's label 0, which is a negative sentiment for the inputs. But again, we'll see how we can actually deploy this in an app here in a second. But if I did open up this inference.py, that's where we're doing that quick classification, where we're reading in the model, and then we're just basically passing in the text and getting a prediction returned from the NLP pipeline part from Hugging Face. So let's go back to the notebook. I know this is a lot to cover. It's a lot to cover in kind of an hour, so I'm going through pretty quickly. Depending on your experience, this might feel really fast or a lot. Maybe it's not enough, like I'm not using LoRa or Unsloth, depending on if you've fiddled around with fine-tuning before, but hopefully you're having fun if you're following along. The next part is we're going to serve the fine-tuned model. So now we have this fine-tuned model. Hopefully yours is done training as well. If not, it should be pretty soon. And we can go ahead and run this next command. And again, I'll open up more code files here, but we're calling union deploy apps app.py and calling a function in there called BERT sentiment analysis. So now if I go to, first I'm going to open up app.py. And this might look somewhat similar. Make it, again, really easy for you to build containers and access infrastructure directly in your Python code. So here I'm declaring image spec, what packages exactly I want to pass in here. Also, you can pass in different things, like if you need to apt-get install things like a C++ compiler or anything like that, you can also declare it in here. It doesn't have to be just Python packages. It could be a lot of different container setup parameters. Here, we're just using transformers, union runtime, accelerate, and then streamlit, because we're actually going to use streamlit to kind of build a UI around our app here in a second. And then we are initializing our application. You can give it a name. I'm calling it BERT sentiment analysis. And then the main thing is I want to have an input to this app every time it's initialized, which is a BERT model. And we're calling fine-tuned model IMDb, or fine-tuned IMDb model.query. And this is the artifact that we passed out of the fine-tuning function. And if I actually go back to the UI here, you'll see these different tabs on the side. There's this one on the bottom called artifacts. I can go click into this, and I can see that I have this fine-tuned IMDb model artifact, and I can click in here. You can add more details like a card if you wanted to, but I can look at lineage here. And this is the artifact that came out of this workflow. So if you pass this in different tasks or different workflows, you can actually have all the lineage stored here as well, which is convenient. I can click in. I can go to the exact workflow where this artifact was generated. And I could click on this view outputs, and this actually shows like that this artifact was the ultimate output of this workflow, was that fine-tuned model. So we're basically makes it really easy to manage the artifacts from your workflows. In this case, we're just calling .query. This is going to get the latest version of that, but you can also call different versions of the artifacts. So you could have different versions of models that you want to call down. And then we're saying download is true. So it's going to download the model every time the container starts. And then for the the serving part, we're going to serve in the image that we defined above. And then kind of similar like we saw before, where we're declaring the compute that we want to run in. We do that here. So I'm saying requests is 2, and we want 24 gigabytes of memory, and we want 1 GPU, and we're going to get 20 gigabytes of storage here. And then I'm actually being specific here of calling that L4 accelerator. Again, by default, it would do this. But you can import different types, like I mentioned, A100s. There's actually some A100s in the serverless cluster that you can use. So if you are training a much larger model, you could use A100s. And then the port that we want to run on, we're going to include main.py. I'll open this up in a second, but that's our Streamlit app. So we're going to download our model, basically pass it into main.py into the Streamlit app where it can interact with it. And then we're calling Streamlit run main.py on the server that we, or the port that we declared. And then also we make it really easy to manage your scaling infrastructure. So in this case, we're just going to have min replicas is equal to 0. That means that when people aren't using this, in this case, after 5 minutes, because we can set this here too, and I think the default is 5 minutes. So if people aren't using your application in the last 5 minutes, it's going to spin down to 0. So it's not going to cost you any resources. So you're not going to be paying for that. And then when someone starts using it again, it's going to spin back up. And then in this case, we are only ever going to have one instance of our app. But you might want to add this or change this max replicas to more, like 2 or 3 or way more. And then basically you can have the scaling metric. So if you have more than 2 concurrent users on your app, then it's going to spin up another replica for it. So we make scaling really easily here. Again, just kind of in your Python code of managing how you want to scale your infrastructure. And then by default, the URL you're going to get requires your Union authentication, but you could uncomment this if you want, and then rerun the deployment demand or command. And then you'd be able to have that URL that you could pass off to people that aren't authenticated, and then they can actually like use your application. So if I go back to the notebook part where I ran this app, it says it's deploying. And if I go back into my Union kind of dashboard here, and I go to apps, which says new here, and I can see that I have this BERT sentiment analysis deployed. And I forgot to show you the Streamlit app, so I'll do that right after I actually show you what the app looks like. So here we have logs or overview of what's going on. You can have full logs here as well, like what was going on when it's deployed and when people are using it. Some information about the stuff we just declared. And then here's your URL that you can click on, and this will actually open up your Streamlit app. The first time you open up, it can take a minute. And then here we have our sentiment analyzer. So now you can type in or paste in text. So I'm just going to do something real quick. Let's see. Hello. Let's see if this is positive or negative. I think this is pretty positive. Let's go grab a movie review, kind of like how we actually trained it on, except for we had an IMDb data set. This is Rotten Tomatoes for a new movie. So I know this isn't in there. And there's negative reviews. There's good reviews. Let's grab one and see what it thinks. So here's obviously a very negative review of the movie. And we'll paste this in. And we'll hit analyze. And it's very confident, 100% sure that that is a negative review. Let's go find a positive one. Actually, before we do that, let's find this kind of neutral one. So we have a 3-star. Let's see how our model behaves. Again, we only used a small portion of our data set, and we only looked at the data set like 3 times. So we have a lot of improvements we could probably make in this model. But let's paste in here. We'll hit analyze, and it's this is positive. And I would say a 3-star is probably a pretty positive review. We didn't train our model to do star ratings. We did it just for positive or negative. Let's grab one more. This one's very positive. Let's paste it in and hit analyze. And also predict positive in here. And if I go back right before we wrap up, because we just have a couple minutes here, I can open up that main.py. And this is a Streamlit app. I guess I won't go through all this based on time, but basically we're just adding in the title that you saw up there. We're trying to load in the model from the artifact that we downloaded in the app.py. And if it doesn't exist, we'll go ahead and log an error into the UI. And then otherwise, we're going to just have the text area that we can put in text. And then we're going to return different colors if it's positive or negative. So I know, again, this was like kind of a huge crash course of going through a whole bunch of stuff. Wasn't anyone able to run and follow along the whole thing? Or did anyone? Oh, someone asked some of the differences between Apache Airflow. One thing is, so I think Airflow is like a task scheduler, and you can do different ways of managing the compute behind it. Flight and Union are really tightly coupled with Kubernetes. So being able to basically just declare per task, like oops, let me go back to the notebook. The developer experience of declaring per task the exact compute that you want, and having the versioning. I think in the newer version of Airflow, they might have entire workflow versioning now. But a big thing is like versioning tightly coupled with Kubernetes. Like we make it really easy and scale very heavily on top of Kubernetes, or we scale very, very gracefully, I should say, on top of Kubernetes. We also have a scheduler in here too. So if you want to do launch plans, so like we saw a example of like that parameterized launch form. If I went back to my executions, I hit relaunch. You can also do this on a launch plan. So if you want to rerun this certain days, or we have triggers or anything like that. Also, we have serving. So that's a big differentiator now as well. We also do the serving infrastructure, not just the workflow infrastructure. We also have workspaces in here too. So if you want to create a notebook, actually, like we were using Colab today, I might try to switch this over and just use a compute inside Union now. So you can create a new workspace. You get a VS Code instance. You can run notebooks and code directly in there, and you can add GPUs, etc., in there. And then also artifact management. So we have artifact management. Again, it's easy to pass like the models and data sets between teams. And one of the other questions was, can we have multivariate forecasting with pipeline? I'm not sure exactly what the question is there. You can build a forecasting pipeline for sure. I think that's the question. Also, inside Union, not on serverless, but in the enterprise version, we also have a full kind of cost observability dashboard, so you can see costs between your whole teams, where all the cost is going. One thing I forgot to show here too is if we open up that training task that we just did, we can hit view utilization, and this will actually give us really good insight too of like, we declared that we want 12 gigabytes of memory, but we're actually only using one because we're using a GPU. And same with the amount of CPUs. In this case, this actually doesn't cost that much for us, but it could be way more. Or if you're rerunning this like thousands of times, that cost might add up. So there's a lot of cost observability that goes into it as well. Oh, and one question too about comparing to SageMaker workflow. And again, I haven't used SageMaker pipelines in a while. One thing is local development was a big deal. I don't know if they added that in. Also, with SageMaker workflows, you're tied to SageMaker. With Union, in serverless, you don't think about where your cloud is, but with like the enterprise version, it's bring your own cloud, or there's bring your own Kubernetes cluster if you want to do more on-prem deployment. So actually, you can do multi-cloud, which is a big deal for a lot of companies. They're not always doing every single task or every workflow on SageMaker, for example. And someone said, how can we deploy final pipelines on AWS? So for example, actually, most people that use Union bring EKS, which is the basically AWS's Kubernetes cluster version, into it. And then we help manage the infrastructure. And a big part of this is like allowing your AI engineers or data scientists to get the infrastructure they need with kind of all those best practices built in, like we talked about versioning, caching, etc. Usually when people implement a pipeline like this, they go from doing like model experimentation from weeks to days, and model deployment from like months to weeks kind of thing. So really, really just enabling speed and efficiency across teams is a big part of why you'd want to implement, even if it's not Union, but any type of MLOps infrastructure or tool that's similar, like into your MLOps team, and building out those best practices or enforcing those best practices. Like even if you don't end up using Flight or Union, after today, I hope that like some of this was interesting, like some of the things to think about for optimization, like local development, for example, and caching, and bringing those practices into your team can really, 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 again, help with cost, with optimization, like development optimization, team collaboration, and then sometimes too, you might need to think about compliance, like having lineage across all those different artifacts can be really important. I think it's always nice to have. Sometimes it's more required. Someone said, thank you for the great insights. No problem. I hope you enjoyed it. Again, I know this was pretty fast, and I wanted